So let's switch to open a, there should be, ha, I have it. I'm just going to share a screen. Okay, everybody can see that. So you have two things. You have, just going to take it to flat because it's easier for me to write and it looks a little bit neater. So you have, that is a really thick line. Oh well. Length and force. And of course, this is the maximum that you can get out of it. And so, of course, with the force length curve, you've got two components. You've got the active component, and you have the passive component. So starting sort of at a resting length and then going up. And then the actual force length curve looks something like, follows up to here. And then from there on, you add on whatever's extra. So if I have that there, I would add that much to that. From there, I would add that much to that. And then it's going to follow the rest out. So it's going to, the actual force length curve looks something like that. We're all good with that? This part in here does have an active effect. Once you're out past here, it's only based on passive components in the muscle. It doesn't matter whether you turn your muscle on or off, you're going to get the same length. So this is long over here and this is short. If you think about your elbow and biceps, it's going to be longest if I class, so elbow angle and force. And if 0 is with my arm straight out, and 180 would be full, not that you can do it, but that would be like that. That would mean that this is long over here and this is short here. We all get that? So theoretically, that means you're going to basically look at something that's backwards from that, right? Where you've got the active and you've got the passive coming up. So if it was only for length, does that make sense? If you only did it for length, that would make sense?
Only if you did it for length, then you would only consider the active and the passive in that sense. But then because you also have to consider the angle, then that's why you, I don't know how you say it, because the way I viewed it was only the inverted U with the angle changing, but then I didn't consider the second side of the argument.
Well, so there's two things that are going on at a joint angle. One is you're changing length, and the other is you're changing moment arm. So I'm just showing you here the effect of the change in length, but it isn't the whole story. This isn't exactly what you will get. So this is basically this green line here, but backwards, because at 0, if I'm classing this as 0 being completely straight, then it would look like this. If I called this 180 and this 0, then it would look the same as here. Okay, does that part make sense?
Yeah, that makes sense.
Only in terms of the length of the muscle. So, you know, if I changed here and just went with 0 went right here as 0 is bent. And this is a straight. Then it would look very similar to that in terms of the force length. Because as you bend your elbow, the biceps gets shorter and shorter. So longest when it's out here, shortest when it's here. That's just literally that literally is geometry. That if you, as you bend your arm, if it's bent, and realizing that the biceps tendon is coming from up here, that's bent, and we went with almost straight. It's coming here. You can see the tendon's getting longer. So the longer you do that, the longer it's going to be. At the same time, however, you have another thing that's happening as you bend your elbow, and that is the moment arm changes. And again, the moment arm of the muscle is the perpendicular distance from the axis of rotation to the line of action of the force. So that's a 90-degree there. And you would extend this line of action here. So it would be there. And it turns out that you've got your largest moment arm when your elbow's bent 90 degrees roughly. A little bit less than 90 degrees, but at the point where this is, when the muscle actually is 90 degrees to the bone. So you actually have something where you have sort of a moment arm that's gonna look like this, where this is where it's 90 degrees to the bone, and your moment arm is going to get bigger and smaller. So on top of this part right here, you also have something here. So even though, you know, in here or so you have about the proper muscle length, you also have the most moment arm, so you can get the most torque out of it. So in terms of force length, you get this. This is purely force length. In terms of, and I can't remember if the question asks it, that's the force of the muscle. But in terms of the actual torque output of the muscle, it isn't looking exactly like that, because you have to take into account the fact that the actual moment arm of the muscle changes as you go through. So it will look something different than that. Does that make sense? Because
yeah, I just had trouble to tie them together, because I could understand the concept, but I couldn't represent it exactly graphically. So this helps a lot.
Yeah, so I think what happens is in around here is 90 degrees, but you actually get, I mean, when you do elbow flexion, you can think that, you know, kind of 90 degrees is when you get your max. And part of it is that as you come out here, not much of it is actually rotating anymore. And so it's not creating torque. And out here, yeah, same thing. So you get something that looks a little bit different when you combine the two. But they actually ask for force length, not torque length, or torque angle, sorry, force angle and torque angle. So muscle force is this, And that just has to do with the length of the muscle, but the actual torque output, which would actually be the force if you were talking force that you could actually hold in your hands, then you would have to combine both of those together. And so you would kind of multiply this by this, because torque is force times moment arm, in order to get what the curve would look like. Remember, I can't see chat when I'm in share. So if you have a question on this, please unmute yourself and ask it. I see that there might be some chats. Renat, you have a question?
Hi, yes. I was just wondering about the midterm.
Before we get to that, I'm asking about this question.
Oh, not about this one.
Okay. So, anybody have any questions about this one? Okay. Okay. Yes, it was chapter 6, question 2, additional problems. And as I said earlier, I know that was kind of before it started, I expect to post the grades this evening.
Okay, thank you.
No problem.
That's average?
I don't have it with me. I'll post it when I post it. It's not bad. Okay. Anybody have any other questions? Aaliyah?
Hi, Dr. Moore. I just wanted to ask, sorry, just to follow up with the midterm, if I wanted to know if there will be like an exam viewing opportunity to go over what we got right and what we got wrong.
Yep, there will be.
Okay.
There will